I'm Amit, and I'll be talking about metaclasses today. So, before introducing metaclasses, I'll introduce myself. I'm a SymPy developer. SymPy is a symbolic manipulation library for in Python. It's purely written in Python. I'm a mathematics and computing undergrad, and Pythonista, and a FOSS enthusiast. So everything is an object. How many of you know this thing in Python? Glad. So is a class. How many know this? That's the main focus of this talk today. So let's explore how class is an object. So since class is an object, you can assign it to a variable. You can copy it. You can add attributes to it, and you can pass as a function parameter as well. So since every object is created by a class, let's see. So we have a foo object which is created from a class foo, and the class foo is defined like this. So since foo is also an object, I told you everything in Python is an object. So foo, which is a class, is also an object. So foo is also supposed to be created from something, right? So let's see what it's created from. Now, which class creates foo? So type of foo is type. So does that make sense? Type, what does that mean? Now let's see what a type is also actually a class in Python. So let's see the type of type. So type of type is type. So we have an inception here. So let's see the other side of type. You have seen one side of type. I'll show you the other one. So you can create classes with type on the fly. So let's see what's the signature for that. So you'll pass the class name as first parameter, the name of the class to be created, then the superclasses and the attributes, dictionary containing the attributes, methods, values, and everything. So let's create one. So this is how you create classes in Python. I hope everyone of you have done this. So let's see how type can do this. Now you can do this. And both are equivalent. Both these things mean the same actually. So you can see I have I printed my class. So it says it's a class. So and you can also define methods and attributes. So this is how you define attributes in normal class. And how would you do this in type is like this. You'll pass things into the dictionary. The name is basically the holder, how you call that function, and the other is the value is basically the function itself or the attribute itself. So it accepts a dictionary of attributes and methods. So let's see how we can define methods into it. So this is how you define by a normal way, and this is how you can do with type. So we have defined a method outside somewhere, and we'll just pass the reference to that in the dictionary. So wheel is basically the name of that method, and the wheels is basically a reference to that method. So this is basically what happens behind the scenes when you create a class in Python, and that is done by a metaclass. So which metaclass does that? So let's see which one does that. It's the type which does that. And this is what you thought type could do. So there's a thug life. Thanks, Manoj, for the music. So what is a metaclass? So the false who have come right now, so you have at the right time, so I've just started. What is a metaclass now? It's basically a secret sauce which create classes. This is what I have been telling to the people who have been meeting me for the last couple of days, that what is a metaclass. So this is basically a secret sauce which create classes. So basically the analogy is object is to class, so class is to metaclass. So we have seen enough of them. Let's create one, and let's see some magic how these things happen in Python. So our first task is basically to a metaclass which would keep all the class attributes lowercase. So this is actually a convention pipette. So for example, you're in a company and there are a lot of people in the company, and the company wants to maintain a guideline, coding guideline. So this is a basic pipette. So one way is to tell them that follow guidelines, which is often missed, and the other way is to enforce. So this is what we are doing. We'll now keep all the attributes. This is a bit hacky sort of thing. So this is not how you're supposed to do it, but let's see an example actually. So a guy who has written all the classes as lower methods as uppercase, it will automatically convert them to a lowercase. So let's see how we can do this. So when you do this, this happens, and where wheel is this, right? And we would like to change that. So when we define a object of car, let's say C, and you call dot wheels with a capital uppercase wheels, it should not work, and the lowercase should work. Let's see how we can do that. So we'll write our custom metaclass to change that behavior on top of type. So I already told you that type is very powerful. So type is itself a metaclass. So whatever metaclass we'll write on top of type. So we'll write a new class which will inherit from type. So let's see how we can do that. So this is a new metaclass which we are creating, lower attribute metaclass. Okay, fine. Yep. So we are defining a new class, lower attribute metaclass, and we have a new method in this, and the signature is the same. So first one, lower attribute metaclass, is basically the CLS or self what you pass to the methods, and we'll do some custom stuff, and after we have manipulated stuff, we will return with the type. So basically what happens is when you create class, it goes into the type. Okay. The Wi-Fi is working, fortunately. So basically what happens is when you create a class, it goes into the type, and then type returns the class. So because type is the metaclass which create everything. So now we are hacking that process actually. So you're creating a class, and type is creating the class actually. So in between we are just hacking stuff. This is like we are just hacking stuff to create our own customized class. So we'll do some random stuff there, and we'll see the magic then. So this is how you'll do it. So we have defined dictionary lowercase attribute because the dictionary is what we are going to change. We are not going to change anything else. So we'll see if it does not starts with double underscore. So I'm checking if it doesn't starts with double underscore because there are a lot of magic methods in it, and we don't want the magic methods to be lower be manipulated because that will make the class stop working. So we'll just make lowercase everything else, and we'll just save that into the dictionary which we have defined it, lowercase attribute, and then return with the type, and that will do the magic. So we have written our first metaclass, right? So how would we make our classes use our custom metaclasses? We have right now just defined our metaclasses, and by default, all the classes at the runtime will use type metaclass. So we need to tell Python that we have defined our own custom metaclass. You are supposed to use this custom metaclass. So how would we do that? It's a simple thing in Python 2 and 3. Let's see what's the syntax is. The metaclass attribute. So how many of you use Python 2? Very bad.
We use Python 3 as well.
Oh, I see. So I'll show you in both how to do that. So in Python 2, this is how you'll do it. And in Python 3, this is how you will do this. So let's do this right now. So we have defined the meta class here, and we are going to define a class, let's say class A, and we need to tell that to use this. So it doesn't exist actually. So since we wrote the meta class, which makes all the methods and attributes at lowercase, so it will not work. So we'll have to call with the lowercase. It will work. And if we'll do with this, it will also work. So right now we are overriding new, the new magic method. There are two magic methods in classes. That is, one is double underscore new and other is double underscore init. So how do we know that which one we should be editing? So it's basically a simple fact that when writing meta classes, if you wanted to initialize, you want to control the initialization of class, you should be using new, and if you want to check something initialization, then you need to use init. So this is a simple logic. So let's see some more meta classes in action. So now we need to enforce the requirement that all private methods in project must have docstring. So in this case, if all the private methods in the class doesn't have a docstring, it will raise an error. So what do you think it will use, new or init? Yep. So since we are not creating the instance now, so we are just initializing it. So we'll just do some checks, and if the check fails, we'll raise an error. Otherwise, we'll pass on. So this is how you'll do it. So you have the attributes, and we'll see if it starts with the double underscore, the methods, and if it's callable, then skip, and if there's anything private method, then skip, and if there's other methods, we'll simply check if it has doc attribute, because all the methods in Python have this doc attribute if they have this, and we'll simply check, and if it doesn't have, we'll simply raise the type error that must have docstring. So this is how you'll prevent for example, you have guidelines in the company, this is how you can prevent stuff like this. So you have defined a class here, and we'll see how it works. So I've instantiated the class, and since some methods doesn't have docstring, it will raise an error at the time of instantiation. So creating abstract base class. So Python itself uses a lot of meta classes inside it, and abstract base class is one of those. So abstract base classes are something which are basically meant to be inherited from, not instantiated. So it has a module, ABC module, which implements this, and we'll see how does that works. So we'll create one abstract meta class, and we have defined vehicle, and it uses the meta class ABC meta, which means that this vehicle class is a generic one, and it is not supposed to be instantiated. It is supposed to be inherited, and let's see what happens if we instantiate it. This is what happens, because it's a abstract method class, so you're not supposed to be directly instantiating it. You're supposed to be inheriting it. So if you inherit it like this, it will work. So this is how metaclasses in Python are implemented. So if you'd like to know more about metaclasses, you can go to this reference. One is this one, and the other is this one. The Stack Overflow article does a brilliant job in explaining what metaclasses is, and it's simply awesome. And I would say that's the best resource for knowing about metaclasses, or you can look at the Python doc strings. So there's time for questions.
Thank you very much, Amit. Do we have any questions? Hey, what's your opinion on like an ABC meta versus just, you know, the base class raising not implemented, and so the vehicle's only a problem if you actually try and start an engine?
Okay, so you mean not implemented one. So, okay, so in that you'll have to create your own metaclass, right?
No, just so you've got your vehicle base class thing, and you say start engine, raise not implemented, and then if someone wants to, you know, they instantiate a vehicle and pass it around, and when they start engine, it'll raise.
Okay, so it depends what your use case is. ABC Meta does a nice job. So for example, if you are working in your own company, you have your own structure. So sometimes you want to define your own custom behaviors. So in that case, you can define your own meta class inheriting ABC Meta. So that would also do the job. So it depends on case to case.
You have to raise not implemented error, not implemented. You can do both, but the first one goes horribly wrong.
Any other questions? Over here.
Have you used these in real code, and what are some examples?
It's basically more of when you're creating interfaces. So one of the excellent example of using metaclasses is Django. So Django uses metaclasses heavily and to make the interface simple. So it's like it has given nice interface to the user to how you can define models and stuff. And all the black magic is done behind the scenes. So that's how you achieve those things. It's very useful in making interfaces and APIs.
Another question over here. Any more? Hands up.
So I was wondering, in the slides where you showed how to define metaclasses, the metaclass, you know, is defined as a class rather than as a function. Even though if you look at code, really what it's doing is it's just wrapping type or something like that. So is there anything useful you can do by actually defining methods on that class on any other stuff you put in there, or is that kind of just boilerplate? We just put it in a class just for the sake of it.
Actually, you can have functions which are inheriting, which are you can also define functions as metaclasses actually. So it's not just metaclass doesn't mean only classes. You can also define functions actually. So that can also do the job of a metaclass. It depends what your use case is, but you can also define functions as metaclasses.
So is there anything else useful you could do if you actually defined a method in that metaclass? What would happen? I mean, you've only defined underscore new or underscore
Okay.
init. What about
method? Yeah, it depends. For example, if you want to do some very specific checks while creating the objects, so there will be cases when your logic gets bigger and you want to check some very specific things. So you want to separate that logic into a different function. For example, your object is very complex and you want to check a lot of different stuff. So let's say you have a list of functions. You want to do these checks. If these checks passes, then only you create the class. Otherwise, don't create a class. You don't need to create a class. So in that case, creating functions would be very useful. Methods, actually.
Sorry, this isn't a question, but it's an answer to the previous question,
sure.
if I may, which is that if you've got an under get method on the parent class, the instances have dictionary access. That's what dictionary access is, for example, is that you have an under get method on the class of the object, on the type of the object. So if you want to create classes or types that have dictionary access, their type has to have an under method. So you can't use type, you have to use a subclass of type. Now, you might think this is really bizarre and useless, but that's the closest thing in Python that is analogous to the behavior of JavaScript objects.
And Jonathan has whole talks on that subject available online. Any more questions?
Look, so if an object's being created as a service and some services aren't available.
Sorry?
If
if an instance is being created to represent a service and some services aren't available,
Some services.
Some services, yeah.
Okay.
So
Services,
if some things are no longer present,
Okay.
what would be the best way to fail instead of just not creating those methods to represent that those services aren't available? How would you best sort of, would you raise or would you do something else to say this service isn't available?
Okay. So basically you're asking if some object represents some services and you want to control its creation by a metaclass so that some of the methods does not get implemented. Right. Okay. That's a crazy use of metaclass, and I think you can do that as well. Yeah, you can simply check if in the init, in the new method, you have some, you can have some custom methods to check if that service exists or not. If that service exists, then you will simply append that thing in the dictionary, that service, and yeah, that's what you can do. Did I answer your question?
I was just wondering if there's a particular, the best way to sort of fail on that, if it's just letting the person who's consuming the instance fail, or like as in you would get an exception at runtime, or if there's a nicer way to go about telling the user, yeah, this service isn't available in a more generic fashion.
I think the short answer to that question is I'm not sure. So there are a lot of hacky ways to do it, but I'm not sure what's the correct way.
In that case, let me thank Amar one final time.
Yeah, thank you.